I am live. Okay. Well, on today's stream, on Wednesday, March 11th, 2020, I will be continuing on this Surveyor IPython notebook I created, which is really residing in Jupyter Lab now, not so much IPython notebook. You're actually looking at some of the code I'll be transposing locally that I had done before as part of this project here, Python SEO. I'm sort of starting fresh in this Surveyor directory or repo, and I have only surveyor.ipynb and the stuff from the last video where I showed you about some of the pseudo database infrastructure I would be using for keeping my data. And on this video, I'm going to be taking stuff that I had been using in a prior project and moving what I need locally here, testing, importing stuff from libraries locally. Okay, so to do something like this, it definitely helps to get as much out of your way except what you really care about and are looking at. So close everything you don't need. I'm going to keep this around for a minute. No, I know what I need. I'm going to close out of that and close out of that. And what it leaves you with is the launcher. That's one of the things I'm learning here about Jupyter Lab, is that this launcher never goes away. And if you're looking for ways to get a new Jupyter notebook or anything, you're not going to find it over here. I fiddled around here before, and you really have to do it from this launcher tab. See, there's no Xing out of it. Even if you, I guess, chose close tab, which you can, it doesn't go away. Okay, so we're going to make a new notebook because I do believe we're still going to be notebook based for a little bit. And I'm going to call this one test. Real creative, I know. And the first thing we're going to do there is import the reload library. So it's the strange bit of code that goes from import lib import reload. And that allows you to reload libraries so that if stuff changed locally, it's using the very latest. So there's this concept of external packages in Python, and they're really awesome. It's really awesome the way it works. So, launcher. I just want a new text file here. So we use that sort of ubiquitous ability to get to your locations. I just open up one of these Ubuntu terminals, and this is Ubuntu, even though this is Jupyter Labs under Windows. This with one CD speculator. No, it's not speculator. Similar concept. CD surveyor. I am now in that directory, and I can see the hello I did in that strange test from the last video, the main file we've been using in the last video, and this IPython notebook we just made. But what I'm interested in right now is creating an external library. So I'm going to call it Vim. Let's call it Python SEO. No, Python is too self-referential. ML SEO, Mike Levin SEO.py. And now we are in a library here, and I can make a definition in there, the definition of a function, hello. And when hello is invoked, it simply returns world. So the hello function echoes world. And I can actually fully quit out of that and take a look at how well editing these things works in Jupyter Lab here. Now from our test.ipynb, I am going to import MLSEO. We leave off the .py. It imported, right? So can we do a function called hello? No. It returns a error because hello is not defined. This is a namespace. Hello is located inside of ml.mlseo.hello. There's your world. So it's an external library. And if we go into it and we put the full hello world in there and we save it, saving completed, Control S saves in Jupyter Labs, thank goodness. We go back here and we execute this again. It just says world. It's because this library is cached in memory. In fact, if I were to re-import it, it still just says world. That's because we need to reload it. We have this function called reload. So every time you import it, you can also reload MLSEO. Import MLSEO, reload MLSEO. Reload is not defined. Now, that is raw. That's not actually in there as code. That's why that was happening. I never really did the import. So now I'll get rid of this one, and we run that one, and we get hello world. So just one final demonstration. You put 3 exclamation points after hello world, and now when we execute this again, it has done the reload, and there's your 3 exclamation points. So that is how we have a dynamic external library. And what I want in here now is actually the stuff that I have done from a prior project that I've been moving into Pipulate. So that's under pipdev, and then it's under Pipulate, and then it's under this here. And so this is my Pipulate library, and I think I would like to have those headlines. And we'll test that out right away. This is a great way to test out a few things. I hope I'm not biting off more than I can chew, but it's checking whether we have IPython, which should evaluate true. We're going to probably try that first. Just transpose this one thing. That should actually be able to get to do that. That should be able to execute from inside of here. See, an object comes back. It exists. So that means this bit of logic can be transposed safely. Whether we actually get headlines or not is another question, and you'd have to precede them all with MLSEO. I am going to do something that's probably not considered great practice, but I am going to import this library into the local namespace. Now, when you're using a lot of libraries, it's not the greatest idea, but in this case, import star from MLSEO. And I think reloading it should work. That's an interesting question. Yeah, I'm going to simplify it. I'm going to take back what I said, and for the sake of explicit understanding of what I'm doing, I will keep it as a its own namespace. So now we have some nice headlines, and I can do mlseo.h1. This is a test. And we've got headlines now as a part of our operations. Now, oftentimes I like making my headlines so that you can import them as local namespace, because who wants to do mlseo.h1? So in this case, I am going to break out headlines into their own separate thing. I keep wanting to arrow key to the right over here, but I'm actually editing this stuff here, and it's interesting having such control over this now. Better than Notebook for sure. Surveyor. I want to stay inside the Surveyor directory, and I want to create a new .py file here. New folder, paste, hello. Yeah, at least you can duplicate files. Yeah, I'll do a few things here because I'm not using that hello. I'm going to rename that to headlines. I'll double click it. And then I'll take the headlines portion here, put that under headlines, save it, import headlines, and now we can do hello without the namespace. H1 was not found. Import headlines. Import asterisk from headlines. From headlines, import asterisk. There we go. So we can move this up here, and then we can do, let's see, was that Control M, Shift M? Oh, yeah. Shift M combines things with the local lines. With the boxes that are around it. So get rid of that, get rid of that, get rid of that. Kernel, restart, run all cells. There we go. So we have two external libraries or modules or packages that we created locally. One which is headlines, which we're importing to the local namespace, so it doesn't use its own namespace, so that we have these functions here, H1, H2, and H3, so that we can just have some nice output as we develop our app. It's nice to have these headlines to sort of label things. People might say, oh, you should just, make code markdown and stuff, because these can also be markdown fields where you can change things around, like when you execute that, it has much the same effect because that is a markdown field. I find it confusing to mix those things together. Why not just use Python and have much clearer syntax right in your code, have it able to combine together? Well, anyway, I want to accomplish more than that in this video. I want to make a really dynamic library I can start working on and growing. So with the background of what I just showed you, it should make a lot more sense when I just start copying and pasting stuff over from my Pipulate project. For example, persist and persist can be very useful. Those common user agents are useful. User agent cycler is going to be necessary. Foreshadowing of what's coming up. I've been using these techniques already to support these types of functions. the links function, the crawl function, the SERP function. I've done all of these with you on streaming or otherwise YouTube videos. They all can just be dropped right into here. And I know already I want to just change this to, well, I'll keep it this way for now. Don't want to make too many changes from the assumes right off the bat. But we will be importing a bunch of stuff up here that is going to be necessary. We need pickle. Inevitably, I know we need requests. And as I look down this, well, we need cycle from itertools. Now, there's a chance I can just run these things. Run selected. It is ghosted. So maybe you can't necessarily do that from any old .py file. It might have to be a notebook. But I'm trying to avoid notebooks for this import module because you don't want to import a notebook as an external module. Again, that's an argument for keeping everything .py files as you can in VS Code, and part of what I'm doing here is a bit of soul searching to see if I'm going to be staying on Jupyter Lab or whether I'm going to be going and yielding to all the pressure that's out there to go to VS Code. There's a tremendous amount of pressure being applied on the world to dump, name your poison and switch to this poison. It's not poison, it's a good tool. But Sublime, Atom, TextMate, PFE, Notepad++, Edit Plus. I could just keep going through the list. Your text editors and your IDEs will always let you down. Only Vim and Emacs will always be there for you. They're part of the fabric of this world. These third-party vendor-specific IDEs, well, they might serve you well today. I don't know if you want to base your career and muscle memory on it, so maybe, but I am not convinced yet. So for right now, I'm going to continue this project in Jupyter Labs. So I'm just pulling in the libraries that we need, the itertools. We need the name tuple, which comes from collections. We're going to need URL parsing, which comes from another odd library, and the regular expression matching objects, so import RE. URL parse, that's a weird one, I have to check. Oops. From urllib.parse, import URL parse. I don't use, well, URL join could be useful. Maybe I'll get that as well. Okay. Okay, so I am going to momentarily pull these little imports over to a new launcher, and then new, I'm getting used to this stuff. And title, try doing the imports, make sure I don't have the imports wrong. Yeah, okay, it all imported well, so if it imported well there, it's going to import, well, here as well. I import it. Now you see the reason for this reload. That library is going to be quite dynamic. And that's amazing that no errors have occurred there. It probably will when I start calling these functions, but MLSEO has some really nifty functions in there right now. The ones I alluded to on the last video is the SERP one, which, yeah, okay, fine. Let's give it a shot. I should be able to do MLSEO.SERP, is it singular? Yep, and then the keyword, and I'll do num equals 100. Linux. Num equals 100. And we want that to be something. We're going to say result equals, or it should be, it is a single SERP. Let's see what errors I get. No errors. So if we look at the SERP there, yeah, see? Pretty nifty, isn't it? This object here is the response object of the requests package. So all the stuff inside here is all the stuff people are familiar with from the request object, from the Python request object. I may have to import the request object, or the request module, for this stuff to make sense in this context. I'll find that out soon. But inside of there is a list, and inside that list is a tuple that has URL title combinations, which have been extracted from the SERPs, just in case you need the titles. The position in the list equates to the position. And there's a few wraps. That's all this is, down for 100 entries to the closing square bracket and the closing tuple. So this is a function that I had written before that actually just does a simple hit against Google using a very standard URL, allowing you to set a number equal to something, which I set to 100, and a little bit of regular expressions to pull out the URLs and the title tags. And I do believe I use this persist stuff here in order to drop it onto the hard drive so that you have a local copy. There it is, SERP default, so that I can load that object. Okay, so this warrants a little bit of explaining. Doing this step is often quite expensive. And to get this object back, it's like, oh my god. You have to re-execute one of these queries against Google asking for 100 results per page. They're going to identify you as someone who's abusing their services. Well, just don't abuse their services. One would normally think that if you were to do kernel, restart, and clear outputs, that you would have to execute this whole query again against Google, be potentially a not polite neighbor, and get the CAPTCHA challenge, which you have to solve, which you can do on your local machine to be back in business immediately, or wait for the timeout to expire. But you don't have to do either when you know that you can. So if I were to just execute SERP now, that restarting the kernel emptied all those values, all the advantages of the REPL environment, read eval print loop, is sort of wiped clear until you do these things again. Now keep in mind, this is the only expensive one here. So I will re-execute that top one. There's no, hitting the search engines there. This SERP is still not populated, but if I say SERP is equal to mlseo.persists, because I know it persists, and I just need to give it a file name, which happens to be SERP default.pkl. The cheater's way of avoiding typing. Now, without re-executing that SERP against Google, there is that object fully populated again. So that should be worth the price of admission for most people. And I'm going to do what I've been forgetting to do, which is to go and see if anyone is there. Ooh. Wow. Flick Gaming High. I thought I was going to have to use a delay or something. Yeah, hi. And let me avoid ignoring my base by breaking out chat and using Windows 10, Windows 10's magic little snapping stuff. Okay. So, right there, I've taught you enough to do a heck of a lot of stuff on your own. But what I really need to do now is, let's see, there's a couple of things to break this down into next steps. I need to make sure that I can crawl sites based on this sort of stuff. So look at how kind of ugly that kind of looks to deal with. We don't have to go back to this response object from the requests package anymore. We don't really need these title tags. So I can hear doubles of you. Oh, thank you, Homeless. You guys are back. Maybe I have two microphones on. Jeez. I'm going to have to fix my audio situation at some point. But that should be in the OBS software. I have one audio capture, although it does say input capture and aux mic. I wonder if I can mute one. Testing, testing, 1, 2, 3. Is it still double of me? Well, let me know as I go. I'll get to this next point, which is to make a list that has more object structure there than you really need, more consumable. What you want to do is list comprehension. Well, first of all, you can just say instead of the whole object, you can go to the first element in the object, which will skip over the response object or the requests response object and jump right to this list. So you can see it chopped that off. Oh, no more doubles. Yay. Okay, thanks so much, Homeless. Thank you. I'm still working out the kinks. Streaming is very strange. The OBS software is very strange. This stuff that you for some reason have to get to know in order to do this streaming is tricky. It's not straightforward, I guess because screen capture is involved. So the next thing after you chopped off the first element in there is list comprehension. You can say X for X in, which will return the same exact object, but now you have access to the API of the single elements, of which you can grab just the first one, which is the URL. Much prettier. Now, there is a chance that there are duplicates in here. Unlikely because it's Google search results, but the shortcut notation for doing that would be just to throw those curly brackets around it, I do believe. No. Okay. The second thing is to do the set function, set Yeah, that's more like it. So there you see the curly brackets. It's there as representing the object in memory, but you can't use curly brackets quite as freely as you can square brackets in representing lists. But at any rate, that ensures the uniqueness of that list of URLs. And I'm probably going to want to resolve all these landing pages to get the real landing pages and not just the ones that were sort of told to us by Google. Now, that is a potentially long wait visiting each of these and resolving the landing page URL. However, that is really the next step, so I probably shouldn't avoid it. Although, let me think this through. This is a great place to be for extracting landing pages and positions out of SERPs. Although I probably lost the SERP position from doing all that list processing I just did, especially the set stuff. See how stuff looks a little bit alphabetized here? If I take the set out from there, it should probably go back to its natural order, where these positions represent where it was in search, and it in fact has. And I think I might want to actually do that. There's a way to keep the position as you turn it into a set. Let me think through. I just don't want to go down the wrong avenues here as I do these things. Think. I want to do a crawl of these sites, a crawl of one site after another, and start using that stuff I was telling you about in my daily journal. Not in the daily journal right now. Where am I? Yeah, no, that's a one over there for work. So what I do is I go here, I hit J, I go down a bit, and we see my last entry. And so category and SERPs is kind of now covered. Oh, there's so many interesting places to go with this. Yeah. Okay, so while this is pickling the results locally, deliberately, through that persists that I threw into the function, that is in fact a backup, almost like a temporary thing during development, because I had something much better in mind that I want to do to sort of show the power of Python and to get these miraculous shortcuts for very little. So to make this easy to look at again, kernel restart and clear output. You can never do that too often. Okay. So where we're going now is a decorator cache. PI Cashier. That is a very good cacher. Now this, by the way, is patterned after LRU cache. Another interesting one to look at is LRU cache, and you can see I've been looking for things like making LRU cache persistent, and I found this Cashier under PyPy for trying to figure out how to make this built-in LRU cache that's built into the regular standard library of Python into one that could actually survive sessions. It doesn't have to be through the same, python.exe execution cycle. Surviving restarting kernels, I guess, in Jupyter Lab terms. So since this is a relatively new install, I do believe I can just try importing Cashier and see if I have it on this system already. CACHIER. Oh, I do have it on this system. Okay. So I am going to move that up here. Shift M it. No. Control M. Oh, no, it's having it selected and Shift M. Shift M. Oh, I'm doing Shift Enter. Shift M. There we go. Right? Saving myself one copy paste. The real PEP 8 thing would be to put anything not from the standard library at the bottom of the list. However, I like to make things in increasing length. Increasing length. I think it looks best, so I would rearrange that like that. And so now we have this thing called Cashier. That means that any function decorated with Cashier is going to keep its results locally, so that if you call that function again, it will in fact pull it from a local cache rather than going out and hitting, say, Google again. So the function that does it, the SERP function, doesn't live in here yet. This is where I imported it. So I get rid of that and I go over to here and I import it up here. Okay, so we have Cashier in this package. And again, the strong reason for doing the reload here of the library, because this is now an external package in sort of dynamic growth. And what we're going to do is we're going to decorate the SERPs function, or the SERP function. And it usually begins with @Cashier, the name of the decorator function. And I only know this because I have used this library before. And it's a very strange notation for people who haven't used decorators before. But all this is doing is making sure that any call to this function is first, in fact, fed through this function, which is going to take the responsibility of passing all the arguments along exactly as it's supposed to. It's really a clever way these decorators work. But I will remind myself again of how we do it. Just a stale after, just a number of days. You can decorate a function with Cashier almost as simply as I did right there. There's the ability to clear cache. You call the function name that has been decorated. And there's going to be a default for how long it keeps the days, time delta, stale after. So I'll do that. I'll explicitly control right from the outset how many days the data is good for. And I'll keep the SERP data for up to a week. Now the magic. We go back over to this. We re-import it. Okay, DateTime is not defined. Got to get my tabs right. I generally hate this whole tabbed environment. I like, full screens. It did not like not having DateTime. I always got to see whether I am doing DateTime.DateTime or not. So it's just using DateTime itself. In fact, it's just using time delta. I don't like that example. Look at that. Ugh. So now we can say from DateTime import time delta. Module object is not callable. What object? @Cashier. Let's get rid of the reload for a second. I wonder if it's because of the reload. I'd hate to get rid of the reload because it means we have to restart our kernel. every time we make a change to the external library. Open, open, close, close. Ah, yeah, of course. Open, open. No, I do think I have it right. Let me get rid of the default number of days. See if it still has the same problem with the import. Yeah, okay. I'm going to get rid of the reload, which means we don't need this either. It makes the code much simpler, but every time I make a change to that external library, I have to change it here too. But let's get the payoff. I will allow this to execute. So it's actually doing that, hitting the Google for the results. Now you saw that little delay it had. Unfortunately, that little delay is my only way really of telling that it's going to hit against the cache this time. And it was actually on the long side. I am not that optimistic that that didn't hit the Google directly again. But we can sort of test these things to see if the cache worked. There's some really fancy ways to test this to make that not hit Google on the network again, having to do with rerouting DNS, but we won't go there. I think I'm simply going to put a side effect inside of this function here, inside of SERP. So time, DateTime, time showing Linux tick time. I forget what they call it. It's like time, tick. Second sync setback. Yeah, okay. Other people have had difficulty coming up with that name of that feature as well. And so I have an untitled sitting here for testing stuff like this. From time import GM time. Ugh. You know what? There's a really old trick for this. If you're not sure how to convert one of these complex things into standard string, you just do Python string conversion and see what Python's decision is. Oh yeah, percent string. Oh, could not. Oh yeah, okay. So this, you can't put it in there because that is in fact a tuple with lots of separate objects. It's not as easy here. Let's see if I can spelunk it. That is a real long shot. Okay, so I do need the strf time. Yeah, probably just strf time. Let's try that. Time objects have an strf time. Strf, yeah, time. Or not. strf time. Oh, has its own separate function to import. You know what? That looks pretty close to what I want. Just so that I can see that the side effect is not being re-executed. Long way to go, but yeah, plus seconds. You know what? We don't really need that plus thing. Let's just try this. And every time we execute this, that's going to be a different value. See those seconds changing? You know, it's going to be different seconds all the time. So we got this guy here, and this is testing our cache to make sure that what we're doing here is really cached. So we do need those time imports at the top. And in addition to the time imports, we need to go to where the SERP function is occurring and put in a side effect printout. So that's saved. Kernel restart and clear all outputs. Now the reload isn't as important because we forced a reload with a kernel restart. Oh, module object is not callable. That's the same thing as we had before. CACHIER import MLSEO is not callable. Hope it's not just a simple spelling mistake. Import Cashier. and that is a function being defined. And oh, from Cashier import Cashier. It's one of those things where you can't use the library's own name, but there's a lot of packages out there that work that way. But this tripped me up, and I'll be able to put the default time amount back in there as well. But we only need that portion of the Cashier library, which is fine. Everything's fine. Sometimes I wonder if I'm still streaming. This says I'm streaming. The YouTube tab says I am still live. Look at that. I've been going almost an hour. Not receiving enough video to maintain a smooth stream. Well, anyway, if you guys want to say anything to me, I'll be sure to keep an eye open. What, I have three concurrent viewers and 3 likes. Thank you very much. This seems like such small, inconsequential stuff, but this is really the underpinnings of everything. Once you're caching SERP requests, right? I mean, okay, so there should be a side effect now when we call this SERP function. The side effect is the printing out of the time at which it was called. I shall use some of the functions as they're intended to be. Copy selected cell. Paste cell from clipboard. Re-executing this should create the same exact, this should not change, that 26 should not change. Oh, and it didn't create the side effect at all. That is just as good. I could have printed foo there. Ye of little faith. So these things can be architected in different ways. These cache things can attempt to keep side effects. They would have to be programmed to attempt to keep side effects, and I just assumed this one would. But given the fact that no output came back from the second time I'm running this, and it's almost instantaneous, or the third time I'm running it, chances are that that is quite thoroughly cached. And even that pickle that I'm doing internally to make sure you can get that stuff back through persistent stuff is not even necessary. In fact, that at this point, once Cashier is used with it, is just cruft. You look at it, you go, what the heck, why do I have that there? So I'm gonna change it. Def SERP. Here's our SERP function. And I'm just going to tear out the stuff that has to do with making the results persistent. I do not need that. We'll get rid of the whole file name thing. It's an easier API to remember, the keyword and the number of results per page, right? There's persist and persists, and I saw just before it wrapped back up there, it was just that one use. It just drops it down on the drive if you didn't give it, but I don't think that's necessary, and I'll tighten this code up a bit. Now, it's an interesting thing knowing that this function has been refactored a tiny bit, whether that's going to have a bearing on the caching or not, but let's find out. It's re-imported. No side effects. Okay, now let's do that next step, which is kernel, restart kernel, and clear all outputs. Restart. And you'll see the numbers disappear. Okay, and I am going to get rid of a lot of this stuff. Node.js is awesome, but your brain gets wired different. between JavaScript and Python. Mine got wired Python. You will notice, though, that in my profile, I got Node in there. Oh, I deleted it, didn't I? Oh, well, it's not my profile, it's my vimrc. So when I do @n, I take whatever JavaScript's in my Vim console and dump it into Node.js, which I always have installed on my machine. You know, when I talk about Linux, Python, Vim, and Git, I put Linux first for a reason. It's the way to get your code running. If your code is in Node.js, and there's 1,000 reasons to do that, then more power to you. I do this stuff greatly because it's Python, believe it or not. A tool should not have that much bearing on your workflow or anything. But truth is, I am able to think clearly in Python, and I've never been able to in JavaScript. And I've tried getting onto JavaScript more than one time, although it was before the days of Node.js. And I try and keep an open mind, and it's worth another try. But for right now, I get rid of all that, and now I've got this. Okay, I can do what? Shift M, is it? Shift M. Okay, so now my code is really this big, and most of this code here is just that I can reload the friggin' library as I make changes over here. But you'll notice my SERP object just gets repopulated after a kernel restart. And without that side effect thing, that means that my SERP object has the SERP result populated into it, just as if I had used a database. Yet there is no database in the picture. And when I'm not putting a key value in. This would sort of be the key value. I get an object value out. But that is our next step, right? I've only done the SERP function on one word, Levinix. But the idea is I want to do this on a whole bunch of words and turn them into key value pairs, with this being the value. Now, once again, there's the whole issue of whether it's persistent in memory or not. But so long as I architect it as a function, I can use that cashier to do this same sort of caching as I go. And then as my final step, maybe bind it to a real database backend. Someone said SQLite all the way, and SQLite is a wonderful way to go because it comes with a Python standard library install. I just lack the knowledge of how to tie the two together, but I'll probably do that if I get rid of this SERP thing here, because who needs to look at that? Look how nice and clean the code is to look here. From the stuff I told you earlier, you know that I can have a list of keywords. Number one trick. Levinix. What else should I put? Pipulate. Mike Levin SEO. And I don't know, other stuff. I mean, I'm not going to position anywhere on this, but Python tutorials. Python live stream. I should start to get myself known for Python live stream, right? Or Python live stream tutorials. You get it. The list, it goes on and on. Now I could just execute this, and you see it is a string, and it's showing you these \n here, and a whole bunch of interesting stuff is going on. This is Jupyter Labs' way of showing you its interpretation of a string. If you put a print function around this, it won't do those \n. It'll use real line returns. Print respects the line returns, whereas Jupyter Labs built-in, show them a string representation engine, however they do that, doesn't. So you can set a variable equal, to this keywords equals that, but it would just be a string if you were to print keywords. Well, it's just a string. So what you want to do is split that on the \n. Now it's at least a list, but you want to chop off the first and last entry from 1 to -1 on the index. And now here are your keywords. And so this is a function that is very easily called per keyword. Now, an interesting thing about these caching things is normally you'd have to populate an object and commit that object to some persistent location to get some sort of database behavior, but really not so when you're using something like Cashier on the back end. Well, let me get that time delay because it's nice for me to know explicitly how long these time expirations are. I'm going to go back to 7 days. So it's like a 7-day database. I keep wanting to switch tabs up there, but it's down here, and I hate having to use tabs. I hate having to use the mouse, but these tools are much more accessible to you than the other tools that I advocate, which is Vim. So Vim is what you're moving towards. Jupyter Lab is where you get started. So what was the point I was making here? Okay, so I don't really need that. So whatever the default is fine for now. But I can say for key in keyword. Now this is the part that just really blows my mind. Because that caching is there, I can just feed that search for key and keywords. Okay, so asterisk, it's doing each of those. Yeah, right, see? Whenever it gets new input, it gives you the side effect output. So you're not going to get one for Levinix because it had already gone through that function. You get 1, 2, 3, 4. 1, 2, 3, 4. There. Just as expected, 5 keywords, 4 side effect outputs with a difference in times there. So it was worth doing that little exercise. But now if I take that same loop and do it again, how long you think it's going to take, what kind of feedback you think it's going to have, it's instantaneous and no feedback. Okay, so you've got the SERP results for these keywords actually cached locally. If you looked into it and you went through the documentation, you could find out where it's actually putting it. It's kind of an on-faith thing here, but look how little code here it actually takes to do that. That's because of this external library that you saw me, create here, basically extracting it from one of my projects, pasting it into another project so that it's an externally loadable library. Now, just to show you that that is the case, we can print a few things on each of these loops. We can print the key. Okay, so that's what key is being used. But bigger still, we could print what's coming out of here. We could say, foo equals that. And now you can print. You could print foo. Why not? Let's go ahead and nuke Jupyter Notebook a little bit. Again, I gave you really good warning with the output not abiding by line return. Well, I'm using the print statement there, so it's because the sub-objects. Okay, well, anyway, you can see all the data is there. You can kind of see where it's breaking, but the fact is it's actually just like it's in a database here. We can start looking inside of it. You remember if we grab just the first object off of each, it'll get rid of these response things. So the response is gone. And now we could do another subwalking. Well, first I can do a print empty so that we can see the spaces in between the keyword search results. And of course, it's 100 results per page, so it's some scrolling before you find those empty print statements in between. But this is why Python and SEO are synonymous. Look how little code it actually takes to do this. Now, that is a list. So we could say, and it's a list that actually contains URLs and then the title. And we're not really interested in the title in the next step we're going to do. So what we could do here is for item in foo, I guess let's give foo some meaningful thing. This is a SERP, right? For item in SERP 1, so it's skipping over the response objects, print item, but not just item, because if you grab the first item, it's that full tuple, including the title tag. We're going to grab item 0, which is the URL. So there's your nice clean list of URLs, and then you'll have the spaces in between as the keyword switch. So the search on Levinnik switches to the search to Pipulate and so on. Where are those spaces? Is that true anymore? I took the print out there. There was a print that was here. That now will make the spaces between keywords. So the search on one ends and the search on the other begins. Which keyword is which? Well, of course, you're sitting on the key, so you could totally print key again there. Now you'll start to see why I have things like H1 in there, right? It's so much more pleasant to look at this stuff when you're dealing with real HTML-like headlines without having to switch back and forth between Markdown or not. Okay, so what next? So these are really nice URLs. Now for each URL, I want to do a quick crawl of the site, really. And I also want to start filtering out sites that I shouldn't visit and do a crawl of, like GitHub. And I want to start preventing crawling the same site more than once. So there's that's actually a different Levinnik, but I'm sure there will be duplicates of sites through here. Google tries to reduce that and give everyone a fair chance. I'm going to do a filter of sites that should not be crawled, just so I don't waste my time on a few of these, like GitHub, news.ycombinator, but Twitter. Most of the rest are valid, but let's put a filter in so that we know we're not going to be going against certain sites not to crawl. So similar to how we have a keyword list, we can have a no crawl. And in no crawl, we'll put things like github.com and a few of the others that were too big. ycombinator.com, twitter.com, and reddit.com. So I have a no crawl list in memory, and I can just say if not in, if Oh, very interesting. Okay, yeah. So I'm not going to put it in the loop. It's got to be inside of here. We've got to say that the URL equals that item 0 and parts equals URL parse URL. If parts.netlock not in no crawl, then print URL. Thing lengths will go to not type, right? And it's stupid because we make mistakes anyway. So let's see if that works. GitHub and this line. Okay, URL parse is not defined, right? I imported it over there, but not over here. Ah, wrong tabs. Muscle memory. Ah, yuck. And then I just did a whole bunch of moving stuff around. Okay, at least getting back to where I thought it should be was the same. Was what I thought. Okay, so from URL parse, we'll need that over here. I'll leave URL join off of it for now. We re-import. DateTime is not defined. Name DateTime is not defined. Oh, did I take the import out of it? Oh yeah, I put that back in there. And I had shortened time delta down through the style of my import. From DateTime import time delta. Okay. And Levinix, Mike Levin, all right. Ah, news.y Combinator is still there. I probably just misspelled it. And I see Reddit as well. Reddit, Y Combinator, and GitHub. Reddit.com? That looks like I spelled that correct. Twitter. Very interesting. Reddit.com. If parts.netlock not in no crawl. So it's not choking on that. Let's just quickly go down here again. Oh, it's netlock is keeping the subdomain in the picture. So I might have to do full subdomains. Let me look at the parts. I'm going to print all the parts because maybe it's something other than netlock that I want. We've got scheme, netlock, and netlock does contain the subdomains. That's exactly what was going on there. And I don't want to try stripping down to the apex domain right now, twitter.com and www.reddit.com. So I am going to, for now, be very explicit about the subdomains in the no crawl. So it got Y Combinator wrong because of news dot. It got Twitter wrong, I think. Let me put an extra print between these so that we can be a little more clear. www.reddit, www.facebook. And this will be a good filter to get started for the next step. Let's get rid of all that ugly extra printing. And now we just know that those sites like Facebook and stuff are excluded from here. Now I'm going to be interested in crawling just a number of these, not all of them. Let's say, YouTube. Let me put YouTube in there. I'm going to take I'm going to get a few more in the don't crawl list. YouTube, LinkedIn, www.youtube, www.linkedin. Okay, so I'm going to make this top out at the first 5 sites that it encountered. So we're going to do I, items in enumerate. Enumerate is one of those wonderful Python tricks where you actually have a counter sort of built in. It won't make any difference to how this runs, but since you're in a for loop, you can say if I is greater than 5, break. And now you're just going to get, up to 5 for each. And if a lot of the sites are those offending sites, you're going to get less than 5. 1, 2, 3, 4, 5, 6, 7. So I is probably keeping a leaky value as it goes around. I hate to clear okay, you know what? That's because that's down there. No, it's not. It's because it's not out there. Yeah. But still, 1, 2, 3, 4, 5, 6, 7. I can understand 6, but not 7. 4. Yeah, okay. Because this if is inside of another if, that number could have gotten bigger before it encountered that if statement. So let's do it near the top before a print even occurs. Now 1, 2, 3, 4, 5, 6. In order to get that 5 I was expecting, I turn that to a greater than equals. 1, 2, 3, 4, 5. Okay, so it's up to 5 per. Now I should make it 5 per if it's not in that crawl. So after all that work to create that counter, we only want to increment the counter if it has gone through that for loop. So after all that enumerate stuff, you see it's a nice lesson here. I equals 0, and we only want to add 1 to it if we have printed it. I believe it's I. Well, I'm just going to do I equals I plus 1. I'm going to surely get comments that there's a better shorthand notation for that. But there you go, 5 clean URLs to crawl per keyword. Oh, crawl, you say? Well, crawl is also a cacheable function, believe it or not. Now, crawls do come back a little differently each time just because of the nature of these sites. But I have a crawl function in that same location as where I have ML SEO and all this stuff. Links, crawl. I should be able to. It's using its own internal caching as well. There's the taking care of pickling for yourself is nice, but sometimes it makes the code too complex. I have this thing about whether you're restarting, and restart is set to true. I have some stuff I need to rethink a little bit now that I'm using the Cashier decorator. However, I am going to go ahead and take the decorator that I have used on Cashier and put it onto both of the functions that are used in the crawl, the links and the crawl itself. Now that means I may be emptying or clearing the cache on these two functions fairly often, and I'll probably put a function in here to do that. But as long as the parameters that are sent to these functions are the same, it should in fact cache the results of these crawls. Now, there's also plenty of output from these functions as it crawls the site, and I think without any further ado, I should go ahead and make it crawl 2 from each keyword. I just don't want to wait through 5. And instead of a 500-page crawl, I'm going to make it a 100-page crawl. I'll probably be sorry for it with the cache stuff later, but instead of merely printing the URL, I can set some arbitrary object, which we don't even need yet because the caching is storing all this in a local database just by mere virtue of calling the function mlseo.crawl, the URL. Execute. Oh yeah, I need to reload this stuff because I made some changes. It doesn't matter if I run this stuff over again, but there's no harm in it. And now, the moment of truth, still an error. Path is not defined. Now, that's funny. Is that actually in this library or that library? Yeah. Geez, had I pulled path out? That's odd. Oh yeah, I just didn't bring path in. I was making this whole file fresh. So sometimes the first time I call these functions, it illuminates for me that I have not done a import. One of the most important ones you'll ever do, from pathlib import path. It makes so much of the old pains in Python less painful. But of course, since I changed that, I need to do the import again. And moment of truth. Next error. It's going to be more imports. Beautiful soup, a few things like that. There's probably ways to mitigate this. I'm going to have to get used to Jupyter Lab. Some of my muscle memory is still for Jupyter Notebook, and that reiterates the danger of building muscle memory on volatile platforms. Moment of truth. Boom. One more import, at least. Beautiful soup is not defined. I thought I just defined that here. Was I not watching what I was doing? I was not watching what I was doing. I put beautiful soup in the wrong thing. It needs to be in the imported package, not the IPython notebook. Now I'll just jump right down. Okay. Local variable, all links referenced before assignment. Return all links. So it got to all links before it got through any of this. I am going to, oh, this does use that pickle stuff well. You need to do housekeeping. This is actually a case where some of this internal stuff, it's good to have done the pickle stuff, because visited sites yet still to visit, and boy, it's been a long time. Let me make sure I'm still streaming. Yeah, I'm still streaming. I still got 2 concurrent viewers, 3 likes. Interesting. Wow. Before assignment, return all links, but all links does get referred to here as we build stuff, but some of the logic is going to make it skip that. Now I did make a new directory, and I don't know if oh yeah, it should have created the pickles. Let's take a look if cd pickles. Oh, hey, wait a minute. cd pickles. There should be a pickles directory in there. If not, pickles exists, make their pickles and crawl. Oh, it's not pickles, it's crawl. Yeah, cd crawl. And here is the 3 pickles that do the housekeeping on the crawl. They're all very tiny, so they haven't been used. They're all like 5K. Now I did change the name of it from pickles to crawl, but I don't think it should have any impact, because all this looks pretty solid. Restart message for a link and enumerate unvisited file name. So it could be that some of these sites have no followable links. So I'm going to do the really easy thing and just initialize all links because its data type is a set. I can say all links equals set, and I'll at least have a all links variable by the time it reaches there. And maybe it was the crawl of the first site it encountered that it messed up on. You always got to keep the input data in mind as well, because first one to visit was levinix.com, which I know because I made it. It's just a slideshow that might not have ahref links on it, and it doesn't. That is something I will have to address. So this visited is going to go up to 100 for each of the sites before it says done crawl. And then after this is done, see, all this stuff is side effects now of the crawl. It's going into the cache. Now, it definitely will have to make a way to clear that cache, but without even saving stuff anywhere, just because I have the crawl function decorated with the Cashier package, it is putting it in local as if database storage. Look at the amount of code. Now I remind you, people are saying, what about Node? So I got a few imports. I got a few lists being built in a ridiculously easy way because you don't have to deal with square brackets or JSON notation. You don't need to look at it again. That's waste. This is waste because MLSEO SERP. Yeah, this is the doing that. This was the example, putting it in memory. You don't really need that. You don't need to look at that. So the whole program so far is almost pure, logic and very little syntactical sugar decorator. These are the sites you don't crawl. These are the keywords. And then for all the sites that come back as a result, you do a crawl of those sites. Now this one is not finding Well, this is a good way to test a crawler too. Visited is not going up, but unvisited is going down. So it's not reaching the I have visited this page thing, but it is using up ones it has found until this is going down. This is interesting. So many edge cases and crawlers. I might put some limit if number of times it can go through these loops, because these crawler functions are kind of open-ended. What is crawling a website after all? This will finish the crawl before visited even increments at all. And that's coming up real soon. I guess I'll watch that, but I got to make sure to see why making an entry to the set of visited sites might not ever go up, what the condition is. Clearly not being able to visit the page, but it's not a showstopper for the script. So we went through Levinix. It's 2 keywords per. So Pipulate, it's 2 sites per. That was the first, that was the second site. Crawling up to 100, crawling up to 100, crawling up to 100. So it's 3 sites per. Oh, I did I equals I plus 2. Jesus. And then I didn't. Oh yeah, here's the greater than or equal to. But I am getting a little impatient, and I am going to. Well, okay, I'll let it go a little bit more. The point is, we're going to run this again, and it's going to zip through without the side effects. And then the result objects, which I'm just sort of throwing away here as it iterates through the loop, because crawl equal, I'm not doing anything on each iteration of this loop of crawl equals. So that crawl contains all the data from the crawl. Everything that returns back from the crawl is going inside of an object that I'm really not doing anything with. So we're doing this for 1, 2, 3, 4, 5 keywords. It's up to Mike. Now it's not going to have anything on these. I might just skip these for now. And so when it gets done, Mike Levin SEO, we're done. So I'm going to hit escape 00, which is a way to stop it while restarting the kernel. I wish there was a way to do that while we cleared all outputs from the kernel. Because you get that nice empty sort of thing. And now I'm going to go through this again. And even the crawl should be super fast with its cached output. And it is not. Well, let's judge this. Yeah, no, that's fast. Some of these may not be well, actually, I'm not sure. We'll see in a second. Yeah, that's not as fast as it should be for cached output, even on a crawl. So I've got a little more to check in here and to clean up. It might have to do with default parameters and stuff, because for the caching to work, it's got to be exactly the same parameters each time, but I don't see why it wouldn't be. This is very strange. I don't want that. And it finished. It got through those 3 really quick, and some of those included a large crawl, which was definitely not represented here, although a few did go pretty big. I'm just going to execute this last one again and see if it doesn't just slam through it super quick. And it does. It's showing the URL without showing all the side effect functions. So there is the crawl going on. There, that's what I was expecting. The crawl is cached too. And even though I'm throwing these objects away, I can at least take a look here, and you can see how there is so much in each of these crawl objects, and that is just one of the various ones. That's from the last step through, so that's on Mike Levin SEO, and you can see it's a set, so you can just sort of reach in there. You can get the first item from the set. It makes it a lot easier to look at. It's not subscriptable. Says you. Look at that. you can just sort of step through these. So those are the results of a crawl of the site. There are other things I'm going to be doing at this point, but this gets really most of the important parts across with profoundly little code for what it's doing and profoundly little database connectivity for what it's caching and keeping locally. Again, you'll remember there is some stuff that I did in earlier coding sessions where I do in fact do some what you might call or think of, I'm using Vim shortcuts here. I'm going to have to either turn Vim shortcuts on inside of Jupyter Lab or stop using Vim shortcuts in Jupyter Lab, one or the other. But I'm doing some database stuff here with just pickles, local, lightweight, non-real database back-ended, but using the file system on the crawl. But that's only so that interrupted crawls can pick up where they left off. It's kind of like single session rerun protection in the REPL environment, because each crawl is going to overwrite, I do believe, the default pickle files. We can take a look there by looking inside of crawl. Yeah, these get rewritten on each crawl. You see these numbers go up and down based on how many sites got found. So there is a little bit of complexity. There I go again with my Vim shortcuts. But there is a little bit of complexity being hidden because we're getting all this stuff in. That's the external library, the external module, with this one tiny import at the top here that makes all that code available in this file from this file. So I think I've gone on long enough there. I've got the foundations for what I need to do superbly well in place. This is all the stuff that SEOs always talk about. Well, you can do this, you can do that, but they very rarely turn around and actually do the coding to do it, because everything feels or seems like a big project, but it does not have to be that way. Things can feel and seem like much smaller projects once you have the right external modules designed and being imported into your projects. That's greatly how frameworks work in Python and a number of other languages, just kind of extending the capabilities of your language, giving you new commands and occasionally new syntax. I didn't do that here, but some libraries certainly do that. So thanks for joining me, and hope to stream to you again soon. And don't forget to subscribe, and don't forget to let others know about this wonderful hidden secret you found in my YouTube channel, Mike Levin, youtube.com/MikeLevin. Thanks, and see you again soon.